So I have all of my data right here, and I added them all together, and then I divided by the total number of data. So that is the mean, also known as the sum of all x divided by the total number of observations. And we found that to be 19.25. So the next thing that we're asked to do is to compute the 5% trimmed mean. So we see that there's some outliers in this data. And the outliers that I see are these first two numbers here. 2 and 4 are really far away from all these other ones. And all these other numbers are pretty tightly clustered together, but 2 and 4 are really far away. And we were talking about last time how the mean is something that is sort of, in a bad way, overly influenced by outliers. So last time we were talking about how for data with a really long tail, I think I had data for how much money people make, and there's this really long tail of people who make lots and lots of money. So there's not very many people who do make lots of money, but the people that do make lots of money make a lot of money. So we would sort of think of an average amount of money that people make as somewhere near the peak of this distribution. But because of this really long tail, the average salary that someone makes is all the way out here because it's really influenced by these people that make a lot of money. And because of that reason, the median is a better measure of center. But if you want to use the mean, what you can do is trim your mean. So let's just get rid of all these people who make tons and tons of money and calculate the mean of everybody else. So that's what a trimmed mean comes into play. So a 5% trimmed mean means that we are going to delete the lowest and the highest 5% of all of our data. So there's 20 data sets here. 5% of 20 is 1. So if we're going to compute the 5% trimmed mean, we're going to compute the mean without the 2 and without the 28. So we're doing this symmetrically. So we didn't really, looking at the data, 28 wasn't an outlier. We didn't really care that we got rid of the 28, but we're going to get rid of it anyway so that we have the 2 and the 28 that we get rid of. So if I push second answer a few times in my calculator, there's all of my data. I'm going to delete the last piece of data, and I'll delete the first piece of data. And now I have my 18 scores that I can compute for my 5% trimmed mean. So I add all those together, and now I'm going to divide by 18 since I now only have 18 pieces of data. And I have mean is 19.25. The 5% trimmed mean, I'll go ahead and round that to 2 decimal places so we're not doing overkill here, is 19.72. And the last thing that we have is to compute a trimmed mean that's 10% trimmed mean. So let's do the same thing. So I'll go second enter on my calculator a couple of times, and now I want to get rid of the first 2 data entries. So that's that I'm not going to include the 4, and I'm not going to include the 27. And so now this is getting rid of both of our outliers. So this is probably going to be a more representative mean that's not strongly influenced by that 2 and 4. And we'll get rid of the 4 and the last 27. And now we're going to divide that by 16 because we only have 16 entries now. And I get 20.25. So every time we deleted one of these outliers, our mean got higher. So the last thing I have you doing here is which of the 3 means provides the best measure of center for the data. And to my eye, this is the better measure of center. The mean is not as low as 19.25. It's really higher. It's about a point higher than that because we have these 2 people who showed up on test day for the first time and just guessed on everything and only got a few points. But these two people aren't really representative of the class as a whole. The class as a whole kind of got an average of about a 20 out of 30 on the test. Okay, so that's means and trimmed means.